All right, people, we are going to change things up a little bit, and I am going to do the teacher-directed part of this video on loose leaf paper and talk you through things, see if that works a little bit better for some of you. Last lesson that we had, we were given some plus and minus tiles or negative and positive tiles to represent the movement on number lines or on a number system. Today we're going to be using positive and negative signs to model expressions with integers. If it is a positive number, it's going to have a certain number of positive tiles, and negative numbers are going to have a value of -1 times however many negative tiles we need to represent the number. For the first problem that we're going to be talking about, it's problem 258, and we are going to be drawing. And I know that sometimes we hear drawing and we kind of go, whoa, but we're going to be drawing some plus and minus signs to represent positive and negative tiles. And we're going to try to represent a problem that we see. So in the first one, we have an example that was done for you, and it is -8 plus 2. And the way that the book showed you this example is they drew something that looks like this. So we have -8, 1, 2, 3, 4, 5, 6, 7, 8, and we're adding 2 to that. Now, when we add 2 to this, kind of cool thing with the positive and negative tiles is we can put them together in a I call this a zero pair, and you'll hear that term in other places too. So we have -8, 8 negative signs, 2 positive signs, and we just proved that this answer is 1, 2, 3, 4, 5, 6. So that is equals -6. In the next problem that we have to do, we have -5 plus -3. We start with 1, 2, 3, 4, 5, 1, 2, 3. And if we put all those together, we should have -8. This is our proof. And I understand that some of us don't always want to show our work or explain, but we really do make stronger, more solid connections in our brain when we do some drawing. It pulls on a different part of our brain so that connection be stronger and more solid. The next problem that we're going to take a look at is 2 plus -4. I only put the parentheses around here because you see this in a book, in the math books. I'm putting them around there, up there too. It helps to divide or separate, I should say, the positive and the negative sign. So we start with representing our 2, and then we have 1, 2, 3, 4 negatives. And if I put these together, and then I put this one together with that one, which is kind of a silly way to do it, but they are a pair, I end up with, we'll put the answer over here, -2. For the next problem that I'm going to demonstrate for you, we have -7 plus -7 more. So that is 1, 2, 3, 4, 5, 6, 7. And we can put the rest of them up on top here. 1, 2, 3, 4, 5, 6, 7. Doesn't really matter how you draw them as long as you have all of them drawn out. And when I add that up, I end up with -14. 2, 4, 6, 8, 10, 12, 14. The next problem I'm going to demonstrate for you is 4 plus 3, -4 plus 3. So we can put our -1, -2, 3, and 4 And then to make it easier to partner them up, I could have done it like this, but I'm going to put it like the one on right just above here. So I'm going to put in positive 3. And each of these makes 0. So we are left with -1. And that is our proof. Another problem that we have is -4 plus 8 plus -2. So we'll start with a -4. 1, 2, 3, 4. Put those positive 8s just above them to make it easier to visualize and group. 1, 2, 3, 4, 5, 6, 7, 8. And then we have 2 more negatives to put in here. And I'm going to put them over here so we can see that I had 3 different groups of numbers that I added. You can do them however it makes sense to you when you get to here, or get to the situation where you're drawing. I can circle all of these because those all make a 0 because there's the same number of positive and negatives. Circle all those. And I end up with +2. 2 more problems and then you're going to be on your own. -3 plus 5 plus 3. All right. We could make a guess here because some of you see that there's 2 numbers that are having the same absolute value. But right now we're going to go ahead and draw our picture. So we have -1, 2, 3. We have a +5, 2, 3, 4, 5. And then we have a +3. So we end up with 1, 2, 3. And if I get rid of or combine the 0 pairs, I end up with a +5 left over, which makes sense because -3 and +3 would make a 0. Last problem, there was one that was very similar to this on your assessment, your formative assessment last week. And actually, it was on your homework for the last time, 222. So let's take a look at this problem. It's -6 plus 6. The problem you had was -4 plus 4. So I'm going to go ahead and draw my -6 tiles. 1, 2, 3, 4, 5, 6 negatives. My +6, 1, 2, 3, 4, 5, 6. And I end up with 0 because they all cancel each other out. All right, time for you to get started on your independent student work. When you are doing the first problem, you certainly can tab a little bit and then you can use your keyboard to make 5 minus signs and whatever else you need to do for the problems as you're going. Please remember when you see that absolute value goalpost, and I'm going to show you what I mean right here. When you see the absolute value, that means that I understand that inside is -5, but I want the absolute value of that, and I'm going to add it to the 3 plus the 6. Okay? As usual, there will be a review of this lesson for you. Well, I'm planning on it for the next day. Conference hours are through Schoology at 9:30 for compacted